Today's video is on quadrilaterals. A quadrilateral is just a four-sided polygon. So to start with, I want you to think of how many different quadrilaterals you already know, and you can list them on this page. So stop the video now and list all the different quadrilaterals that you know. Okay, so now that you've got all the ones that you know, we're going to take a look at the special ones that you need to know. The first one, hopefully that you were able to name, is a square. Okay, so a square is a really special quadrilateral. A square has four equal sides, and I'm gonna show that with four equal dashes. And what I would suggest is that using the space below these shapes, you start to write down the points that I'm making. So I'll do the first one for you, but I'm not going to write all of them. But you should be writing things like four equal sides. Okay, so continue to write those points down there. A square also has four equal angles, and they're all right angles. So we would show that like this. Okay, so four equal sides and four equal right angles. A square also has two pairs of parallel sides. So we'd show this like this. That side is parallel to that side. Should we show that with the two arrows? And also the left side is parallel to the right side. So because I'm talking about two different parallel sides, I'm going to mark it with two arrows. Okay, so two sets of parallel sides. We also need to look at the diagonals in any shape. So a diagonal is just the line that goes from corner to corner. Okay, and in a square, the diagonals, they bisect each other. So what that means is where they cut each other in half. So that half of the diagonal is equal to that half, which is also equal to that half and equal to that half. So all four of those sort of halves of the diagonals are equal to each other. And the diagonals also intersect at a right angle. So all the way around there, all of those angles there are 90 degrees or at right angles. Okay, the second quadrilateral we're going to look at is a rectangle. So a lot of similar properties to a square, but a few big differences. So one of the big differences you probably already know is that all of the sides are not equal. We have two pairs of equal sides. So that side and that side are equal. And then I'm going to put two lines to show that side and that side are equal to each other. Okay, we have four right angles like we have in a square. So four equal right angles in a rectangle. And we also have two pairs of parallel sides, just like in a square. So that side and that side are parallel, and then this side and this side are also parallel. And if we take a look at the diagonals of a rectangle, so I'll just draw those in blue. So here's the diagonals of a rectangle. You can probably already see that they don't intersect at 90 degrees, okay? We've got two sets of sort of vertically opposite angles, but they don't intersect at 90 degrees. They do, however, bisect each other. So now this length is equal to this length, and I'll show that with three lines, which is also equal to this length and this length. So the diagonals bisect each other. Third quadrilateral is a rhombus. And a rhombus is similar to a square, it's just sort of tilted to the side a little bit. So in a rhombus, we have four equal sides, just like a square. And we have two pairs of parallel sides, just like a square as well. So that side and that side are parallel, and that side and that side are parallel. But we don't have four right angles, okay? However, we do have the opposite angles being equal to each other. So if I said this was angle X and this is also angle X, they're the same measure, the same amount of degrees. And then this one here, if I called this one Y and that one Y, those are equal to each other as well. And you can hopefully see that X and Y are co-interior angles, just like we learned in our last video. Okay, let's just have a quick look at the diagonals of a rhombus. So let's draw those in. And we can see those do intersect at 90 degrees, okay? And they do bisect each other. So that side, that side, that side, and that side are all equal to each other. So we've got diagonals that intersect at 90 degrees and they bisect each other. Okay, our fourth quadrilateral is a parallelogram. It's a big long word, parallelogram. Okay, so a parallelogram is kind of like a rhombus and a rectangle combined. So we've got, like a rectangle, we've got two pairs of equal sides. So the top and the bottom are equal to each other, and then the two sides are equal to each other. And again, we've got two sets of parallel sides. So those two sides are parallel, and those two sides are parallel to each other. We also have angles, opposite angles equal. So just like in a rhombus, that angle and that angle would be equal. And this angle and this angle would be equal. What else? They're not 90 degrees, the angles, as you can see. Let's take a look at the diagonals. Okay, just like in a rectangle, the diagonals don't intersect at 90 degrees. However, they do bisect each other. They do cut each other in half. So this length and this length are equal to this length and this length. So all four of those are equal. Okay, next one is a trapezium. And trapezium, there's not much that's kind of sort of special about this. All that a trapezium has to have is one pair of parallel sides. So that's it. Okay? None of the lengths have to be equal to each other. None of the angles have to be equal together to each other. You could have a trapezium that might look like this. Okay, something like that. So we just need to have two pairs of parallel sides for a trapezium. And our last one is a kite. So with a kite, we have two pairs of equal sides. So that side and that side are equal to each other. And then this side and this side are equal to each other. None of the sides are parallel, okay? You can see if you extended all of the sides, they would all intersect. The angles are that this angle and this angle are equal to each other, okay? But that's all that's sort of special about the angles. And then if we look at the diagonals of a kite, you can see the diagonals do intersect at 90 degrees. And the shorter line here, this one is bisected, so each half is equal to each other, but you can clearly see that the other diagonal isn't bisected. So that's a kite. So those are the 6 special types of quadrilaterals that we need to know. Now, a quadrilateral can either be convex or non-convex. So this one is a convex quadrilateral, and what it means is that all 4 angles, so all 4 of the angles are less than 180 degrees. So all angles are less than 180 degrees. So all the angles are either acute or obtuse. But in this one, in the red one, that's a non-convex quadrilateral. And what that means is there is one reflex angle inside the quadrilateral. So you can see that that angle there is more than 180 degrees. So we've got one reflex angle. Okay, looking at the angle sum of a quadrilateral, what we can do is we can think about what we learned about angles in a triangle. So if I cut this into 2, or if I so if I cut this into 2, you can see I've got 2 triangles there. And you know that each triangle, the angles in each triangle will add up to 180 degrees. So that means that the angles in a quadrilateral add up to 360 degrees, okay? And that's just like a triangle. For every single quadrilateral, the angles need to add up to 360 degrees. So we'll just do a few problems using what we've learned about angles in quadrilaterals. In this first problem here, I need to work out angle A and B. If you look at angle A, you can see that angle A and that 77 degrees are co-interior because they make that C shape. So that means that they add to 180 degrees. So A plus 77 must equal 180 degrees. So to work out A, I would subtract 77 from 180 degrees to get 103 degrees. And like we did with the problems with the angles, you must write down the reason that you knew that those added to 180 degrees. And again, that's because we had co-interior angles. Okay, now to work out B, I'm going to use the fact that I know that B and 77 degrees are opposite angles in a parallelogram, and I know that opposite angles in a parallelogram are equal to each other, so B must be 77 degrees. And again, I need to write down my reason. Opposite angles in a parallelogram are equal. Okay, you could have also used the fact that you know that A and B, you can see those are also co-interior. You've got sort of a C that's flipped around there, but A and B are co-interior. And that would have given you the same answer, and that would have been perfectly fine as well. Okay, let's look at the second problem here. Here we've got we've got a quadrilateral, and we know 3 of the angles, but we want to find out the last one, and we know they have to add up to 360. So we know that angle A that we need to find out, plus the ones we know, 100 and, oops, not 110, 115. Let me just erase that. 115 plus the 100 degrees, plus this angle here, which we know is 90 degrees, they need to equal 360 degrees. So I'll add up the ones that I know. So 115 plus 100 plus 90 gives me 305. So A plus 305 degrees has to equal 360. So to work out A, I would subtract 305 from 360, which gives me 55 degrees. And again, the reason I knew how to work that out is because I know angles in a quadrilateral, sum to 360 degrees. Okay, so that's the end of our video on quadrilaterals. You can complete your summary for this video and your question for class tomorrow.